Detroit Chinese Engineering Association. This is the first in-person event since pandemic. So now the spring's here, the COVID is gone, and birds singing, trees blossom, and we're gonna have nice food and a night with our friends. So, right now, let's move to the VIP introduction. I'm gonna have Godfather help me. My name is Jenny Remington. I'm your MC tonight, and Godfather our co-host.
Thank you, Jenny, and welcome everybody. Thank you for coming. We are honored. Now, allow me to introduce our VIP guests. And it's time for the VIP to stand up, to greet each other, to let us know you. Mr. Mark Wang, the Senior Director of Dassault ShangMI, Simulia. Thank you. Okay, great. Next one, Mr. Zhou, President of Ford Chinese Association. Ms. Rona Lung, the President of APACC. And the Leonie Teichman, the Vice President of APACC. Dr. Guanchen Wu, Chief Engineer of Oancea American Corporation. Dr. Zhongping Zeng, Senior Director of CAACS. Dr. Wanda is not here. Okay. Mr. Mark Huzel, Senior Partner, Asian Chair of Dixon Wright. Liang Yan, Director of East Asia Business Development, Dixon Wright. Oh, she's on the way. Okay, thank you. Ms. Lisa Gray, founder of Dragon Eagle TV. Mr. Shendong Liu, President of Generality. Louis Stamkin, Senior Manager of Infrastructure DevOps Software Factory from General Motors. Mr. Alvin Stu, Engineering Manager of Software Quality Assurance from General Motors. Lu Jin Zhang, our sponsor from Farmington Insurance Agency. Dr. Fan Li, Manufacturing Director from ZJE Electric. And I have to apologize that due to the and our special guest, Kun Han. Due to the limited time, I have to apologize that I cannot address every VIP guest. I apologize for that, and I actually appreciate all your support and all your understanding. And I hope you enjoy tonight. Thank you. Thank you.
Thank you, Donna. And we have distinguished remarks from 4 other distinguished guests. The first one will be Mark Wang, Senior Director This as Simulia.
The subtle Simulia.
I really did not prepare anything formal. I do want to thank DCE for hosting us today. I think it's clear for most people that Zoom is not so good. And it's nice to see people in person. You cannot build relationships, share knowledge, develop community unless you meet in person like this. So thank you for hosting us today. I look forward to talking with many of you.
Thank you. Dr. Wang Wu, Chief Engineer from Oancea Power.
Thank you. Good afternoon, ladies and gentlemen. So I'm very happy to be invited here. Actually, I'm a Detroit because I lived in Detroit for 20 years. And before I joined HI, I worked in General Motors for more than 3 years, and also worked in Detroit. So since I'm here, I just want to introduce a little HI. So Weichai is a Chinese company. So Weichai means Wei found diesel, just like the Detroit diesel. So everyone knows so Weichai is Wei found China diesel company. So we are the number one in the heavy-duty diesel manufacturer by the volume. So in the 2020. We have 1 million of the heavy-duty diesel produced. So 1 year is 1 million. So by volume, we are number one in the world, around the world for the heavy-duty diesel. And then right now, we not only for diesel, we also cover every area like commercial truck and construction machine, agriculture area. And also, we also have a company in Italy. We acquired a company with the luxury yacht. We acquired the company in Germany. We called Kia. It makes forklift. So it's the second largest forklift manufacturer in the world. It's just by the Toyota is the number one, but it's number two. So our revenue from overseas right now has become 40% our total revenue. So that's our the total overview of Weichai. Actually, right now we call Weichai Power. So the last year we have the total revenue like $380 US dollars revenue. It's a rather big number. We are the, I think in the 500, global 500, within the 500. So we are very happy to support the Detroit authority engineers. So we will continue to support, and we will welcome the Detroit engineers to support our company. Thank you.
Thank you. Ron, the president of APAC.
Good evening, everyone. I am Rona Long, the president of the Asian Pacific American Chamber of Commerce, also known as APAC. On behalf of APAC, I wish to thank the DCPA for your kind invitation to join you this evening. APAC is now celebrating 23 years of facilitating meaningful relationships between businesses owned by Asians and U.S. corporations, entrepreneurs, and professionals. We represent 30+ Asian countries across the globe. It is meaningful partnerships such as the one that APAC has with the DCEA that allows us to continue to move forward with meeting our mission of establishing meaningful relationships. We thank the DCEA for allowing us to continue our partnership with your wonderful organization. I'm glad COVID is over. As Mark said, Zoom doesn't cut it. I mean, it has its purpose, but to get further with establishing relationships, we all need to be able to see each other in person. So once again, I wish to thank the board of DCEA. Thank you, and everyone have a wonderful evening.
Thank you. Mr. Zhou, President, Ford Chinese Association.
Thank you, Jenny. Again, thank you very much for DCEA for the invitation. And I see a lot of Ford Chinese engineers, for retiree or alumni or the current Ford employee right here. So we really appreciate your support. And I really appreciate for the invitation, and I think it's a great event. Just like Luna was saying, Mark was saying, the COVID is finally over. We are not going to have a Zoom, so we really enjoyed a wonderful Chinese food over here and wonderful session to listen a lot of the session from the expert. And hopefully everyone enjoyed. This is really a great event. Thank you.
Thank you. Now it's my pleasure to introduce the president of DCEA, Dr. Zhou Ni, and he's also called Walter Ni. He's going to give us an annual report.
So, this my name is Zhou, because we have another Walter in my board before, so this is for that. But you can either call me either name. I'm happy to. Walter or Zhou, either way you feel like. Okay, where's my slides? Here's some.
Presentation. Short slideshow. Thank you.
Thank you, Jenny.
Yeah, this is my job. Really,
Like the few of our distinguished guests mentioned, I'm really very happy to see everyone in person. It has been too long, over 3 years. And in the past 3 years, I missed my first son's graduation from medical school, his ceremony. I just watched from the camera, and everybody with a big mask. And also, I missed my second son's entrance ceremony to the college. And it's supposed to be terrible. But today, I'm so happy to see everyone in person. My task here is just to get people together, to see you in person, to communicate, to get together, connect closely with you. Thank you for coming. So my job, this is the job needed to get this report each year. We have not done so in the past 3 years. So maybe a little bit longer, but I would try to make it short because we have a very wonderful presentation later today. Okay, so welcome. Okay, for those you don't know much about DCEA, here's a brief introduction of DCEA. We're the largest non-profit, non-political, non-religious organization. We are independent. Most of our guys are from Detroit, Greater Detroit area, and also from other area, also maybe other countries after their retirement, but mainly in this region. We're quite a long history we have. Established in 1981, and most are with the Chinese background, but we also have all the other ethnic people are our members. Now we have nearly 3,000 registered members. If you include the retired members, we have over 44,000. Our leadership are made of three bodies: the board, tech consult, and adverse report. And DCA has no paid officers, all our volunteers. We are here, all our, so we need your support and we welcome support. The technical council has 31 specialized companies in all engineering field with focus on the automotive industry. Okay, here's our mission. What do we do? Sure, we are engineers, we are experts. So we promote technical excellence and innovations in science and engineering. Meanwhile, also try to provide a global platform for business and a culture technology so that we can get together in a lot of the different reasons. You know, we also help people to find their desired career for their professional development. And also because we are promoting the diversity of the different cultures. Here's, I'll just give a very brief about what this first page. This is a page when I just first joined DCEA, so 2011. This is the then board. You see, some of them are still there, like the friends here. Quite a few people are now already become the executives or some top leaders in big companies. But we are still like you, we are still engineers. So, and this is the current board. The current board, it's hard for us to get together. Like we have like 12 people, but always when I try to take a group photo, always one or two some people are missing. So I have to do this, you say. I think like the top guys or vice president, Jim Lee. You know, I need to mention our Jim and those are like Jenny has just recently joined us, our two, and also executive director, our administrator, Cindy. Those are movie level, right? Movie star level, right? Thank you so much for this our group, our leader, those people make this happen with your help. And this is our technical community. You see, like, you see your faces are so familiar. Alan's there, some people, maybe Jean is there. Where? Jean is at Jean is our advisor. So there's 31, this is our first meeting, happens about 10 years ago. You can calculate that. Wow, if you can't read this, doesn't matter, just let you know what it is. So originally 16 group, but now we extended like this. We're 16. Okay, it doesn't matter, I have pictures. This is what we are really to do. We do this, like seminars for auto specialists and also seminars for auto executives. So if you are common engineers like me, or technical specialists like me, it's fine. Or if you are an executive, common class leader, we also have teaching for support. Can you hear me well? Yeah. Sorry. So we also have this similar for both engineers like you and me, and also have similar for executives how to manage a group, how to manage a company. Because we have all those experts who are good at doing that. And also we have other seminars. This is our main. Next, please. Okay, this is our main majors. Like good. Okay. Let's give some, if that too much, give some pictures. Go ahead. There's some lot of pictures. So this is this is years ago, with 2011. Go ahead. Yeah, this is 2011. So it's not an event we had. Oh, this is a guy, I need to mention those guys. After our event, those guys, do you guys need some entertainment? So yeah, sure. Those guys are all engineers from GM. They are volunteer to give us a performance. Quite a few years. Next, please. Okay, this is one of our tech seminars. Yeah, there's another tech exchange activities. Go ahead. Yeah, another one. Job fair. Yeah, this is another job fair. Go ahead. Yeah, this is GM Executive Director gave us a talk at one of our conferences. Go ahead, please. 2016. There's another. 18. Go ahead. Picture. Go ahead. Yeah. 18. Yeah. I see. Oh, this. I need to mention a few words about this. We used to provide high school students or outstanding high school students with DCEA scholarship for their college study. Now we start moving to support the college students. You do have your kids need help. Pay attention to our website. This is when you see some familiar faces here, some young and Mike is there. So this few years, thank you for supporting the game. Okay, go ahead. Yeah, this is another big part. This night, yeah, this is all the leaders and speakers. Go ahead, please. Okay, that's what we did in the past. And because in the past 3 years we did not do much really. But last year we did co-host the U.S.-China Energy Bridge. And I'll mention more about last year's online event. And also DCEA's board director, Professor Wang, later will have elected as the member of the National Academy of Engineers, the 2023 class in AE. Congratulations. We will have this DCEA's achievement, not your person, only your person. So, and also congratulations to DCEA members, Dr. Zhou, Wang. Jian was not available today, but we have the word elected as ICE fellows. Congratulations. We'll have a brief ceremony later for that. And we also prepare a lot of intensive training classes. Today is just to give you some brief introduction of our speaker. Later they will be expanded into some professional, like 2-day, 3-day, or even longer professional seminars. If you are interested, please pay attention to our website, DCEA. Okay, go ahead, Olga. This is a form. This is from ShangMI gave us a formal congratulations to Dr. Alan and Dr. Jay and Dr. Jay for their technical achievements. Go ahead, Sue. Okay, let me mention a little bit about what we did last year. We did this online US-China Energy Bridge forum while politicians are pointing their fingers to each other. We did some real work to make our cars better, to make environment cleaner. We try to bring the experts from both sides to communicate and exchange ideas with each other. Go ahead. And the theme was electric vehicles and smart grid. We try to produce a low carbon environment, less emission. The topic covers the electric vehicles, V2G, smart grid, climate control, and environment. A lot of advanced and frontier topics. The goal is to try to promote strategic cooperation around the topic reducing carbon emissions. We have 11 presentations from university professors and executives and industrial leaders from both sides. And over 7,000 people attended this event. And Jenny and I hosted this event before, so that's Jenny in May. And co-hosted with our China and US partner, and Michigan's chief chief mobile officer, Trevor Powell, gave a keynote. Remember? And the Congresswoman Pam and the Senate's video greeting. Senator Debbie gave us congratulations letter. So it's draw a lot of attention and make a lot of good stuff. Thank you so much. Go ahead. Okay, that's what we did. Well, we're planning to mention that. That's one thing with what we're doing today. In the past 3 years, or just online, but today we make the on-site and make us to see each other. I see the hands here. I mean, yours is here. Oh, that means it's here. So, Ladies contributed a lot for last year over even online event. The U.S.-China energy bridge. We try to create a clean world with better environment. So while politicians are using harsh words, we are using our technical words to make our life better, make better and clean, comfortable cars. Okay, again, if you are interested in our class seminars, pay attention to our website. Next. Thank you, finally. And this, I need to mention that this event is a result of many of our board directors and tech council members and also advisors. There are a lot of volunteer work to make this happen. We really appreciate their dedication to making our community more healthy, more beneficial to this event. Finally, I hope everyone will enjoy tonight's event and have a wonderful time. Thank you.
ShangMI is going to serve us nice, wonderful dinner. That's a brand new Chinese restaurant, and I hope you enjoy. And we also have a wine setting up at a lobby area, and you just tell your service, boys and girls, and they will bring the wine to your table. You tell them you need a white or red wine.
So we're going to have our dinner. This is why we are here. So I want to introduce you guys the chopsticks on the table. If you're not familiar with them, especially for those guests. And this
Okay,
one,
we have
this
the two
one
chopsticks.
to use to get your food from the plates. Okay.
One
And
for
then-
service.
And this one and this one you can use it freely, you know. Put it in your mouth, whatever you want to do with it. So thank you and enjoy the dinner. Our program will keep on going. And whoever need a fork or let our servant and waitress waiter know, okay? If you need a fork to eat.
SAE Fellow, and a distinguished SAE Fellow. And third one is Dr. Wang. Congratulations. Also, SAE Fellow.
All right, who's try this?
And Dr. Jianpu Lu. All right, so let's have a group picture together.
Congratulations for your achievement.
Congratulations.
The ladies.
Thank you. I also would like to take this opportunity to thank and appreciate our sponsors. Without the sponsors, our event won't be successful. We have Weisai Automotive, Weisai Power, Dr. Zhou. Thank you. Appreciate your support. Next is from Dixon Wright, Ms. Len Yan. And thank you for your support. Give a round of applause. And we engage Mr. Mike. Thank you. Thank you for your support, DCA. From the CAAS, Dr. Zheng Ping Zhen. Thank you. Thank you for your support. Farmington Insurance Agent, Miss Lu Jing Zhang. Thank you. Generality, Dr. Sanjong Liu. Thank you for your support. And from Dragon TV, Miss Lisa Gray. What's the name? Okay.
I can come get it for her. Okay.
Have a group picture. have a round of applause for our sponsor. Thank you. Enjoy the dinner.
Actually, the owner of this restaurant prepared platters for our technical achievement guys. Those Mr. Professor Wang, Dr. Zhou, Dr. Cai. Can you come to the stage again because they have flowers for you? Okay. Again, this flower from Sandy, they only have text, but the flowers from the owner of ladies, okay. The lady was very amazing tonight. So the community is really very happy for your very proud, happy and proud for your technical academic achievement. Hey, Mr. Chen, take a picture with us together. Oh, yeah. So this is the owner of the restaurant. Thank you. Now we have Angel Bing. Okay. Oh.
Can ask for wine
you are enjoying your so far. And now we're going to move to the next session, my favorite session, the technical speech. And now allow me to introduce our first keynote speaker, Professor Alan Zhou. Alan Zhou is a distinguished professor of materials science and engineering at the Ohio State University and the director of the OSU Lightweight Materials and Manufacturing Research Laboratory. With experience, with expertise in lightweight materials and sustainable manufacturing for transformation, he is an elected member of the National Academy of Engineering and a fellow of several prestigious societies. Professor Zhou holds 21 patents and has published over 340 technical papers. Wow, that's a lot. I couldn't finish 300 each on whole lab. Today, Professor Zhou will bring us his deep side about sustainable materials and manufacturing for vehicle lighting. Ladies and gentlemen, please join me in giving a warm round of applause to our esteemed speaker, Professor Zhou. Thank you.
Thank you, everyone. Good evening. How was dinner? Well, there's no such thing as a free dinner. Now I got to talk for 20 minutes. I just earned my dinner. You guys got to suffer for the next 90 minutes. Okay? So nobody can leave. There's no free dinner. So you are earning your dinner now by listening to us talk. So first of all, I really like to thank the DCEA, which is my professional home in Detroit, for hosting this event. I've seen so many, I wouldn't say old, but longtime friends. I would at least acknowledge Jimmy Su. Jimmy was my mentor, advisor, and coach in many ways when I was a GM and also with the DCEA and other Chinese community. I'm very happy to see you here, Jimmy, and you're doing very well. Great. And also many friends here, when they're like colleague and GM, Sendong, we have, longtime friends, and Ho, teacher Ho, and a lot of Minfeng Ji. A lot of old friends. I'm so happy. Not old, long-time friends. We're never old. We were the same 20 years ago. Okay, so do I have the appointment? All right. So I also look around, got a few pictures, old pictures. And I think Zhou would take the same picture. And I was in the middle. I like that so much. Right? And also the board that, by the way, I served in DCEA president 20 years ago. Exactly 20 years ago. 2003. And look at all the activities, all the people you can find yourself. You have in Detroit long enough, like I. Now, I moved to Columbus 10 years ago. Yeah, you can see a lot of people there, right? And I'd like to also acknowledge my wife, Wang. It took 4 years of my commuting to convince her to move to Columbus. I had to commute. I made like 120,000 miles before I can get her to Columbus. But now we're back. So our home is still here, mostly. So I'm excited to be here. I'm gonna make your, my talk less painful. I'm not going through a lot of technical details. I try to be really at the high level. So I'm going to talk about materials and also vehicle lightweighting. That's what I do. I spent 15 years at GM doing that. And after that, I have been with the Ohio State University and still doing a lot of collaboration with the automotive industry for the last 10 years. So I want to just talk a little bit about first the mega trends in the global energy and mobility industries, and talk about how we do sustainable materials manufacturing to support vehicle lightweighting. Jimmy probably recognized some of slides and the colors we used to use at GM. I'm still keeping a lot of published GM information, nothing confidential from GM. Okay. So the lightweight materials is really driving a lot of vehicle lightweighting. The mega trend is fossil fuels still supplies 84% of the world energy. 90% of the transportation energy is still supported by fossil fuel. And the slide is still from a Tesla all shareholder meeting. Our economy, energy economy is dirty and wasteful. So that's just a reality we have to face. Fossil fuel is going to run out one day. We don't know how. You could debate for how long, but one day it's going to be run out. So the global OEMs, many of you are working in this industry, they have all made a commitment, different OEMs, by 2035 to 2050, all these OEMs committed to electrification. Get rid of fossil fuel, get rid of the internal combustion engine. I'm not an electrification expert. I'm just trying to see from a material standpoint how we support. And you see now more, California to ban, sales of gasoline-powered cars by 2035. It's only like 12 years from now. And EPA is going to regulate more in EVs and so on. So that's the bigger sort of mega trend that we face in the automotive industry. And many of you in the EV industry, you can see how EV has really taken off. None of us predicted that. At least I did not expect or predict it. So last year, 2022, there's global sales of 10.5 million EVs. And many of those, majority of those produced in China. Now the European OEMs, North American OEMs actually playing catch-up game in EV production. Not necessarily in technology, but in market and production. So that's the mega trend, the bigger environment that we are living in. Again, this is a slide maybe 15 years old from GM. Advanced propulsion is going to take over EV, take over the internal combustion engine. It's just, either it's a pure battery electric vehicles or hydrogen fuel cell that we still don't know. But whatever we do, the future, for the propulsion, lightweighting is a must. It's a given. So that's the area I have been working in the last 30 years-ish. So I want to give maybe only 3 small examples to show what kind of sustainable materials we can use to support the vehicle electrification or the new energy vehicles going forward in the future. Again, this is a slide used at GM. I want to show you how the materials evolves with the vehicle construction, with the automotive industry. And if you look at 100 years ago, 1906, cars are used to be made by wood and aluminum. So that's actually something everybody assumes steel has been used for auto industry for decades. But when Henry Ford started building cars, he used the wood and aluminum. So that gives us some message going forward in using some of these materials for lightweighting. This is a slide based on published GM information. The vehicle lightweighting, driving it, a lot of that is into the advanced materials, using lower density materials. Aluminum, magnesium, carbon fiber composites are the materials that are being more and more used for vehicle lightweighting. I'm just giving very simple examples. This is not a place for deep technical talks. I appreciate that. Your patience of listening to this. And a lot of this statistics showing the aluminum materials has been used increasingly in the automotive industry. And a lot of that is in the casting area. That's what my research has been concentrating in the last few years. We're doing the vehicle. How many of you have heard of gigacasting or gigapress? Okay, that's the kind of work we started research doing vacuum die casting, getting large thick wall die casting. We did a lot of modeling work. We did a lot of development work, but there's a lot of water analog, a lot of numerical simulation. We have a die-casting machine at Ohio State campus. Not only university with a die-casting machine, but it's not the size of the Tesla size, but a lot of concept for alloy development simulation tools that we started developing. So the project, before I left GM, we developed a die-cast door. It was big enough, but not as big as what this guy would do. And so this is the 9,000 ton gigapress made for Tesla. You can see how big it is. You can see the machine size. When I started at GM, it was about 3,000 ton months, and all these huge rows thanks to this guy. And the only bit I like from Elon is take material science 101. You will read it. So we use that to recruit students for material science. All other kids from him don't read. This is the only material science that you want to do. But this is the Tesla gigacasting. I have a lot of former students now working there. So this is really a game changer. A lot of lightweighting is like consolidate a lot of parts into one piece die casting. And the rumors and saying, well, I'm not spreading rumors, casting is a little bigger. So that is one thing. But what many of you probably won't realize, by using aluminum, you are getting lightweighting, but the production of aluminum actually is very energy intensive. So if you really think about it, to produce one aluminum beverage can, it takes energy like a half can of gasoline. By using primary aluminum, you do not save embodied energy. So our research has been using recycling. So we take aluminum chips and we do alloying, we do development to make gigacastings. So my efforts in the past 5 years is really take the scrap aluminum to make it a gigacasting. So a lot of work is in that field. We have plenty of aluminum. So aluminum is like 8% of our scrap suite. So it's sustainable. Especially if you go to secondary aluminum, that is really sustainable. So that's one example I wanted to convince the audience. If we get the recycling going, we can get rid of the primary aluminum production, because aluminum has been produced for 3 years. So there's a lot of aluminum already in circulation. If you can recycle aluminum, your beverage cans and everything, we can make it, a good die-cast alloy. So, all right. This is just showing material science can be complicated. Doing this kind of calculation, we figured out how to make this scrap into. I'm not going to explain this to you, after the dinner. I probably forgot how to explain, but this is the kind of analogy material science we do, so that we can turn aluminum scrap into gigacasting for the car industry. So this is the machine we did, and the die casting we did, all the properties we get. The next example is magnesium. Myself, we worked on magnesium for many years. Magnesium is also sustainable. You can get a magnesium from seawater. All seawater contains like a 0.3% magnesium chloride. If you take magnesium chloride, you can make magnesium. So there's plenty of magnesium. So we try to use the magnesium lightweighting. So one work we did is we can make a magnesium sheet stamped at room temperature. So that was a big development that we got recognized. And I still love Corvette because I put the magnesium engine cradle on top of that. That was our development we did. So magnesium can sustain at a high temperature. I'm not going through the microstructure metallurgy. You're going to be bored. So that kind of work. So my recent interest has been turned into wood. Because wood is a sustainable material. Because we all do building our houses using wood and things like that. Henry Ford used to build cars with wood. And I can convince you there's plenty of wood. You can always plant trees. All these other materials may not be sustainable, but wood is sustainable. If you make a calculation, every one of us owns about 400 trees. So if we can use trees, use wood to make cars, like the old days, we can save a lot of energy. And wood, by the way, is lightweight. So Well, our recent work is in addition to talking about papers. You know, with densified wood, if you look at the wood is like natural composites. It has these natural fibers and glued together by something called the lignin in material science. And if you can densify the wood, you close all the open cells in the wood, and using some chemical method to take out the unnecessary lignin, you can make the wood as strong as a steel. So this is what we call the super wood. The density is 1.3. That's lighter than magnesium, lighter than any metal. And it has strength of 750 megapascal. I know some people are material scientists in the room, materials engineers. This is as strong as a steel, but it's very much. It's like the 1/8 of the density of steel. So currently, well, obviously, we love publishing papers on the cover of the Science, get papers on Nature. So that's our academic curiosity. But we can turn that academic curiosity making, maybe a wood panel or, some structural components using wood. So I'm very excited about this wood material. Yeah, that's recently what we're doing. So going forward, I'm just showing materials have changed, over the 60 years. In the 50s, it's body in white, it's all steel sheet. Like the men used to be at the US Steel doing all the sheet. And now we're doing aluminum, we're doing magnesium, advanced high-strength steel. And Elon Musk, look at that, the giga casting, the whole underbody is one piece casting. His idea is if you can make foil cast, like die cast, you can die cast a few pieces and make your car body. And he went down even uses stainless steel. So materials actually drives a lot of innovation. By selecting the right material, right manufacturing processes, you can really make vehicle lightweight and sustainability is key. So I'm giving three examples like aluminum, using recycled aluminum, magnesium, and super wood. That's kind of a simple message. My research group at Ohio State, we do a lot of atomic scale calculations. That's how we design materials, how we turn natural wood into super wood. We do a lot of this, understanding the microstructure, doing the simulation, and a lot of our work is supporting not only the automotive industry. I'm also very excited working with the aerospace industry, pushing for sustainable materials manufacturing. I think that's my last slide. Thank you so much. If you have any questions.
We have time for one question. Please raise your hand. Anyone have a question for Professor Zhou?
My question is about plastic material. There's a very good material called P. I'm sure you're very familiar. No, I'm studying materials. But it's a very good material. Do you have any close materials to recommend as a replacement? Because it's really good, but it's really expensive to replace
Yes.
Yeah.
Okay, I'm not sure exactly that material is, but I think it's high. It is.
I just know it's called PEEK. Very strong, very like a thermal, stable, chemically very stable as well.
I think it's a problem name, a trade name.
No, it's not a trade name. It's a composition name. I just out for your information. Quite of interest.
Okay, it's not on my table.
Yes.
Okay, but I'm really happy to know. Okay.
Everybody, please, another round of applause for Professor Zhou. Thank you all. I believe you're already excited about the peak pricing, the melting aluminum, and what else? The wooden car. I cannot wait to have a wooden car. But we're going to have something more exciting. We're going to have the our raffle. Now I'm going to pass it to Jenny.
Yes. Okay, now this is my favorite part. Now we're gonna have a raffle. And then everybody should have a ticket, right? When you come in, they give you a ticket and take it out. Yeah, the first one we're gonna ask Professor Wu to join for us.
Try to get by.
Oh, yes, they did happen.
Okay, 777 012. 777 012. Do we have a lucky winner? Oh!
Thank you. Don't worry, this is just third prize. The second prize and the first prize. Right now, we have three of them is all third prize. So, don't worry. The second one, I'm going to ask Mark to join us.
891 8976.
Thank you.
Number is 777027.
777027. Congratulations. It's your lucky day. Okay, so let's continue the dinner. We have a second wave after the second keynote speaker. And let's do that.
Hello everyone. After we learned about the quick lightning, new technology, the new chip, let's now talk about quality. Now allow me to introduce the next keynote speaker, Dr. Zhou. Dr. Zhou is a highly accomplished CTO at DHC Strategic QA with over 28 years of leadership experience at Automotive company. He is an SAE fellow, ASQ fellow, and an associate editor for 2 SAE journals. Jeff's global influence is evidenced by his training over 15,000 individuals in 20 countries. Have you ever really meet so many people in your lifetime? Jeff had trained so many. Over 30 published technical papers and 3 achieved master design levels. He holds a master degree and PhD from the University of Michigan. His speech topic is APE reliability. Ladies and gentlemen, please welcome Dr. Zhou. Thank you.
Okay, thank you for wonderful introduction. Also, thank DCEA for inviting me here, and also thank ShangMI for hosting this event. Okay, this is wonderful. And more important, I want to thank you all for coming here tonight and the busy day. So first, I ask 3 questions. Does food matter? Yes. Does meals matter? Yes. The food and the meals and the cultivated. That's what we're here. And that's actually, if you Google it, you can find the fold matters, the mirrors matters, okay, the mirrors. Then the third question is, that's the reliability matter. So that's why I'm here to share with you why reliability matters, especially in the AC and the EV. So tonight I'm going to have a long day here, right? So I will keep it simple. Usually, when I do presentation, I do lots of presentation I start with take a photo of all these, see their engagement, their attention, their face to face. After my presentation, I take another photo. So I want to see how their facial expression and so forth. Okay. So then gauge my performance. So now I'm doing the first photo. So everybody take your attention. Capture you and then see how your facial. Okay, that's it. So now let's start my presentation here. And I just want to remind, to share, okay, I had 2 jobs, okay, you mentioned. The first job I was 4 years as a sailor on the ship, doing the ship, after high school before the college. Okay, so that's one. Another one job is my last job was the vice president for the Asia Pacific new model launch and the quality. It's a very demanding job, so that's it. No, my job is kind of even that. Okay, so that's what I'm doing here. Okay, so I will share with you some high-level slides about my presentation here. Next one, and just do it. Okay, here's the outline. Okay, the reliability status of today's technology and the views. And then my second portion of presentation that will be the challenges of reliability challenges of tomorrow's technologies and the views, which is involved the AV and the EV and so forth, right? Then the reliability matters, and then share briefly about the reliability process, how we do to improve. Okay, and let me, before show you some data, let me ask you, do you know how many people died on the highway every year in the US because of crash?
20,000.
100,000, 20,000, one more data point. 40,000. Okay, so that's okay. Let's see. Oh, before that data, I want to just say, hey, the reliability failures is usually in the 3 categories: either hardware or software. I think we have a software director manager here, right? Right, so, there. And then the human area mistakes. I just give a very quick example in terms of hardware failures, like in 1986, I think, right? January, we had a space shuttle Challenger, right? Failed due to O-ring and the low temperature ring. Then burning the oil, then exploded. 6 or 7 astronauts into the high school teacher died. So that's kind of a hardware failure example. The software failure example that I'm not sure how many people are here. The time in 1991, we had the first Gulf War, right? Our Patriot missile failed to tracking, intercept the Scud missile, then end up and the Scud missile kind of hitting our military base in the Kuwait there, and I think the 28 people died. So that's because of software failure. So then there's many software failures associated with the vehicles, right? The human errors, there's lots of human errors in the medical practice. in the manufacturing and in the use of, right? One of the examples, I think Titanic, right? The ship sunk, right? That's due to the mistake of the captain misjudged the distance between the ship and the iceberg. Then crashed, and the ship and destroyed, and so many over couple of thousand people died. So that just give you examples. Okay? No matter what, that's three categories: either hardware failures or software failures or human errors. Okay. Now we get into into the crashes, the fatalities, and the death, and so forth. Right? Just very quickly, sure, this is years. This is how many in the U.S. only. Okay. So, Mark, you're right. Absolutely right. Okay. So it's about 40 or 35, and it's pretty consistent. And that is 20 and 22 over there. Okay. So then we cover about 3,000 billion miles in the U.S. Right? Then on the average, it's like 100 million miles covered. There's one death as a result of a crash. That's just reality. This is the public domain information and so much, right? So that's what we give you ideas, okay? So there are matters, right? And then most of the time it's 94% due to the mayors writing leaders. So okay. Then my next question is, out of the 35,000 people died, how many due to drunk driving? Give a guess. No, how many deaths out of the 30, 35? 10K. 10K? You said 10K? Any other number? 10K?
At least half.
Okay, 10K, at least half, right? Okay. Okay, 10K, you said 10K, it's all right. So basically 1/3 of fatalities due to the crashes as a result of that. So it's pretty much 1/3, right? So that's the reality in ways the numbers, it's pretty consistent year after year. Okay. It's serious, right? So then, next, the question may be harder to answer, so that is really right. In terms of financial impact, right? So then, you can see here fatalities in 2010, we got 33,000 fatalities, which is death, right? And the no fatality there's about 4 million. Then damaged vehicles about 24 million, and then economic cost which is 280 billion. The societal harms about 871 billion, which is involved. Every crash you see all of things involved in insurance, crashing, the police come and the ambulance come and lots of things, the traffic delay and the loss income. Right? This comes from the NISA presenters several years ago. So that's kind of what we face in the U.S. and I believe that other countries have similar statistics to it, right? Okay, so that's the reliability matters and which is the hardware, software, and the human, right? Human errors and so forth, right? That give opportunities to give us, to the autonomous vehicles, self-driving vehicles, then we can get eliminated of human distractions, right? The people doing the testing or white driving or read the book or do other things, right? Get distracted, right? So, or drunk driving, right? So then at least self-driving can eliminate those kind of human distractions during the driving. So that's not right. So that's then also look at in terms of the vehicles, right? The failures of vehicle potential failures of vehicle, right? And then cost recall. So this one, and then the line is just the number of recalls per year. The bar chart is just vehicle recall per year. So that's the big. And then for 2022 last year, and data just come out. So we had like about 1,100 recalls and about 32 million vehicles recalled. And for the time we heard the radio, you read the newspapers, and then all automotive news, and that's what they come up with. It's a lot. That's a lot, right? So we talk about lots of the system, alarm system, and so forth, but really we talk about those quality issues, the safety issues, reliability issues. That's what I'm here. I want to get your attention, like ruin your dinner, but really get your attention when you do whatever things you're doing, and quality and reliability, right? Then this I know there's lots of people doing the ADAS, right? And then we also have ADAS that have come out recently over the last 5 years, and for 2022, about 56 recalls on the ADAS, right? About almost 5 million vehicles. Okay, so then look at the recalls of electrical vehicles. Okay, we're talking about lots of things about electrical vehicle and so forth, right? So that's same thing. The line chart is the number of vehicles recalled, the bar chart is the number of recalls per year. And then for last year is about 40 recalls, 1.3 million vehicles affected or recalls. And then the recalls the company, affect the company brand reputation, and also cause the customer dissatisfaction, because you have to send the vehicles to the dealer, even though it's very replacement and repair, it's their cost not convenient, right? So that's what they got. And so they, it's a software based, okay? In the 2018 software related recalls, about 8 million vehicles into recalls. Lots, right? And then it's very, very important job you're doing. I'm very, very happy that you are here when told me yesterday. So that's so as I said, the reliability failures, right? Hardware, software, and errors and so forth, right? Here's the software, right? And then just look at the electronics. I think there might be some electronic companies here, right? In 2018, so we also in the US, we had like 6.3 million vehicles recalled due to electronics related defects or failures or whatever. Now, all of those things cost money, right? And in every company, every time we recall, it costs lots of money, right? But I do want to share with you the battery recalls example. I didn't put the name of the company and the battery suppliers and so forth here. Just give you 2 examples. One battery recall cost of $1.8 billion to one of the vehicle suppliers, battery suppliers, you probably know that, right? So yeah. So and another one, the battery recalls cost the company, and one of the company or suppliers, battery suppliers, $900 million. So okay, and very quickly. So here's the reliability process I won't go through. As long as we have just make sure we define the requirements, exact requirements, and verify the requirements, launch the requirements, and then manufacture. There are lots of details, and then we don't have the time to talk about here. So the battery, everybody knows the battery cells, module, and the battery pack, and then the major loadings here with you, mechanical loadings, and then the electronic loadings, and the thermal loadings. I won't go through it for interest for the time, right? The self-driving vehicles we have a 5 or 6 level of definition of self-driving vehicles automations. Okay, so I won't go through the interest of that. And then one of things, okay, the key challenges, okay, and you know, the self-driving vehicles, we talk about the sensors, the camera, lidars, and the radars, right? The kids want to detect and classify the object. So therefore, the AI allows the machine learning to make the right decisions for next group of vehicles, right? And one of the things, okay, the challenge is for the camera to detect all kind of things listed here, right? The sun, blur, right? And the snow, and the bird, right? And also insects and so forth, right? And then give you one really examples from camera one week in the Christmas a few months ago, I come back from Chicago to Ann Arbor, driving the driveway, right? The four cameras blocked the right, the third, and I cannot see anything there. When my wife and they clean those four cameras, then I can see clearly what is behind, right? So that's the example. You know, no matter how many the cameras we put there, then we need to also make sure they're working the thing right. So that's just give you. Now, my last few slides, since I'm an SAE fellow, so many people are asking me, Jay, what it takes to be the SAE fellow? So I have a few slides I want to share with you here. So I'm an SAE member for almost 20 years. And then during that time, I published the papers at the SAE conference, just like this week over there, right? And I'm also associate editor for 2 journals. And the waste and materials and the manufacturing, which is I saw Professor Lewis mention about that. And another one was passenger vehicle system. So I encourage you, if you have some topic, want to speak or publish the SAE, and either at the conference this week over at Cobble Hall, or you want to publish something, at least I'm two associate editors of the journal, right? So I'm thinking about when Professor Ruth presented his materials in manufacturing, that we will have some opportunity to collaborate with it, right? So then another thing is, okay, as I said, right now I'm doing lots of things to give back. Giving back to the community, to giving back to society, okay? So I'm a SAE mentor to official platform on a regular basis to mentor young professionals who are interested in the work in the mobility space, right? And also students, and I mentor several students from different universities, right? So if your company, some people are interested in whatever, sign up with the SAE mentorship program. And there are lots of learn to develop ourselves, improve ourselves, and in the different aspects of the career. So that's what my other things I'm doing for the SAE. And otherwise, as a lecturer of SAE, I'm doing lectures for AV reliability and EV reliability at different universities at various locations. And on the left-hand side, that's over Hawaii University, the right-hand side, the University of Central Florida. So that's what that, and then every time I sit there, I'm doing a lecture, I see the students are so lovely, okay? And they remind myself of the student time. So really good dialogue with them, okay? Then that's just a few examples of specific contributions we needed to get involved and contribute to the society, to the SAE, Society of Automotive Engineer, right? Then you have a chance and to go to the dinner like this on Monday, 17th, we have a dinner together. This is a class of 2022 class of SAE fellows. We had a dinner over there and so forth, right? So that's kind of give you some ideas, right? Do your job first, corporate company, right? Business, right? Like you do, like I do the quality and new model launch and so forth, right? then same time getting involved with the professional society, I involved to Society for Automotive Engineers, and otherwise the Society for American for Quality, which is I'm also a fellow there in 2014. So lots of fun, right? When you give it back, you have lots of fun, right? So, but anyway, I think that's that's it. Yeah. Thank you. And then if you have any questions to me, here's my email with my name as a domain rights. Right. Okay, so that's it. Thank you.
That's great.
I want to take another one. I said, after, I have to see how many people leave, right? How many very, very good, right? So then I have a before and then after. Okay, good. Yeah, thank you.
It's time for one question. I have a question for Dr. Zhou. I really wish I could ask. Looks like 2019, it is a good year, right? We didn't have many recalls. Is that because of COVID-19? I'm kidding. Okay. Got question. May I have a please?
All right. So Dr. Zhou, do you think renewable vehicle has made QA more important or less important, or more complicated to do, quality, reliability, or less complicated by doing the renewable vehicle, renewable engine vehicle?
So can you?
Sure. Yeah. So sorry. Too much. Okay. So comparing to the traditional vehicle, right, the fossil fuel vehicle, has renewable vehicle made reliability less complicated to achieve or more complicated to check?
Oh, you talk about the ICE, right? And they just make a similar ICE as the EV, right? ICE internal combustion engine versus the electrical vehicle, right? At least EV has less parts, right? Much less parts. And the ICE engine and then plus transmission has lots of parts, right? So theoretically, the more parts, more complicated, then you have more chance to make a mistake. So that's possible. Quality issue or reliability issue. But everything needs to be attention to detail to make sure that that works to the intent. Yeah. No matter what the technology you put there, you make it work not only in the lab, or use lab-created material, but also in the mass production. So that's really important.
Thank you.
Yeah.
Thank you.
Oh, what's the
Yeah,
okay.
we're gonna have a raffle right now. Get your tickets ready.
Make sure I get a one-to-one microphone.
Yeah.
By the way, okay, let me see here. 89-18975.
Last two digits.
Another one. One more.
I'm gonna have the last winner to do it, and then from this table, you won the second prize.
So keep it all clear.
Yeah. Yes. Yeah. Dr. Zhou, keep shooting that way.
89-189-80.
Not 80? Okay. 89-189.
Let me bring back the prize to the table. Thank you. You're gonna draw the next. congratulations. So, yeah. Shoot that way.
More difficult. The last 3 digits, 970.
It's a different ticket, yellow and red, so you gotta read the whole.
Okay. 8918 970.
The red ticket. Last 3 digits, do it again.
970. I'm shooting too far.
Somebody left? No, calling once, calling twice.
970.
Mouse too hard, no fun. Alright, we're gonna skip this one and we're gonna join another one.
Okay, it's yellow ticket. 777 777 040 040. Yeah, missing one.
041. Last four digits 041. 040. 040, they put as a yellow ticket. Anybody has a yellow ticket? 01 040. Yeah, mine's missing one, right? Okay, calling once, calling twice. Nobody? Alright, let's skip this one.
I need to shoot far. Okay, 777 again, 777 049.
Oh, that's me. Thank you.
Yeah, next one, have to shoot.
Thank you.
Otherwise, you guys just make yourself.
Okay, so, this is, yeah, next,
Thank you, everyone. Now it's time for us to welcome our last but not least keynote speaker, President Zhou Wang from CalmCar. Allow me to introduce President Wang. With over 50 years of experience in automotive industry in Europe and North America, Zhou has held various roles including technical specialist, regional business manager, and management position. I'd like to add one title, mentor of mine, right? When I first got my first job, Zhou was my mentor. Since 2018, he has been working at CalmCar as a company specializing in vision-based perception technology for ADAS, AD systems. Zhou founded CalmCar North America Engineering Center and focuses on testing and developing methodologies for ADAS and AD production solutions, as well as engineering services. Zhou Wang acquired bachelor's degrees from Shanghai Jiaotong University and a master's degree from Taikang University, Darmstadt, I pronounced it right, in Germany. Now let's welcome President Zhou to give us his insight in data-driven development for ADAS and AD system. Right.
Thank you, everyone. Thank you, Dafa, for the nice introduction. Actually, I used to work with Dafa very closely when we both worked in the company BBL. He just actually joined my group, and we are working on daily basis and very close friends as well. So very happy to have him introduce me on this stage. Thank you from my side, and I'm very honored to stand here, provide you with some insight about the work that we're doing. Today's topic is about our development work in the ADAS in the autonomous driving field. We are a very young company, like many AI companies. We are very energetic. We are very ambitious. We wanted to contribute a lot to today I'm going to share some of the work we're doing in the we call the data-driven development work. I think we heard the previous speech mentioning the importance of the quality, the reliability. Actually, this is the same topic, I would say. Data for our development work in the ADAS and autonomous driving domain is the keywords for reliability and for the quality as well. So, first maybe a quick introduction of CalmCar. The Chinese name is Wang. So it's located in, our head office is located in Tianjin. It's founded in 2016. We are providing the AI-based perception technologies to support ADAS and autonomous driving functions. We are also developing the automated parking function for the production vehicles. We have multiple locations across the world, including multiple location facilities in China, and Detroit here in the USA is our Detroit-based engineering center. We started in 2018, and we have also our operation in Germany complex to support our operation in the European market. We have overall around 400 people in the whole company. So why the data is important for ADAS and AD development? I listed some of the keywords to look at in different perspectives. The sensor component data, it lays the foundation for the feature and perception performance. The perception data delivers the performance needed for the high complex automated driving functions. And as you know, also for the AI company like us, we need to collect a lot of training data to train the deep learning models. It drives the maturity of the deep learning models to deliver the performance. We also rely on a lot of simulation data because your real world data is always limited. The simulation gives you unlimited possibility to create the driving scenarios and the test cases. The road sensing data based on the real world characteristics, and we extract the feature of the real world complexity and it turns into the structurized data for analysis. The system data, we talk about a ADAS system, like adaptive cruise control or lane departure warning features, and these system data reflects the level of harmonization of orchestrated sensing and control elements, right? So, in the ground truth data, it's also becoming very important that we need to evaluate and validate how good is your sensor data. We use a reference system to do a comparison against to see how accurate your sensor delivery in the real actual system. Finally, is before the SOP and the release of the feature to the market, to avoid the reports, you need to do a large amount of robustness testing, right? So it builds the confidence of the ADAS functions before the release in the SOP. So this is actually how the data flows. If you look at today, I think most of the company who was working in the ADAS autonomous driving will follow that workflow. So you basically have the data sensor, it delivers the raw data, and then you have a human sitting in front of the computer doing the labeling, or you can rely on some automated labeling process. And then with that labeled data, you are able to generate or develop the deep learning models. And the model is getting also implemented in the real functions, and then you collect deploys those functions on the roads, doing testing validation, and you get this system validated, and then you try to identify if you have some room for improvement. So this is actually a closed loop. It's going to continuously evolving, and also with more and more data, it's basically improving the maturity of your system performance. So there's a lot of testing needs to take place. We talk about the sensor hardware testing. There's also the test of the sensor functions, like our camera is doing the object detection on the roads. And the efficient testing is a very key to the
efficiency of the development. So we do the algorithm development and functional testing, which is largely depends on how efficiently our testing can be performed. So this is actually a quick number for how many tests needs to be done. There's still a little bit old number, but to give you some sense about the mileage that needs to be driven for autonomous driving functions for Waymo and Zhou. So these are the real-world data categories. When we have a vehicle driving a car on the road, we typically divide it into dynamic data and static data. The dynamic data means that we are looking into moving objects. So you basically take note of the objects by understanding their velocity, size, position, classification, and the tracking ID. The static data is like landline, road curve position. These are the ADAS function or the system that in the vehicle needs to understand, like human brain and your eyes and the nose, ears, those your human sensors to understand how the real world is. So if you look at today's ADAS AD sensors, there's many of them, right? But really, when we look into what are the key sensors being used, and we have large categories like cameras, like LiDARs and radar. LiDAR was previously mainly used for autonomous driving function like L4, L4, and L5, but now with the largely used solid-state LiDAR is becoming also a very production feasible element for the L2 plus and L3 functions. So there's some of the work that we are doing. We are installing the sensor on the vehicle. We do data collection vehicle. We have also functional testing vehicles. There's also the data logging systems, how we also integrate our sensor into the existing vehicles. There's some work that we can do in order to do the data collection in a more efficient way. So the data true chain is very important for us to use this data. So we talk about the data logging in the test vehicles. We need to have also the method to replay the data in the offline mode. We also use the 3D cloud point-based labeling platform for using some of the LiDAR data to accelerate the data annotation process. These are actually my colleagues and working inside our facility. They are actually working on the preparation of the data logging system. It's basically the vehicle instrumentation. We need to install those data loggers and connecting all the sensors, making the calibration done properly, doing the synchronization, making sure that we go on the roads and affect the high quality data. So this is actually our CalmCar vehicles we've been driving last year across the whole United States. It's actually, you can see there's a roof mount LiDAR system. It's from the very big LiDAR company called Robosense. They're providing us with the ground truth systems that we're using. It's 128 beam LiDAR, can see 200 meters long. And there's also two side LiDAR, which is 32 line LiDARs covering the blind spot area. We actually mounted also quite a few state-of-the-art high-resolution cameras with 8 megapixel cameras. So you can see there's in total 8 megapixel cameras being used on the test vehicles. Each hour, we generate like 2 to 3 terabytes data. It's a huge amount of data we're collecting. And we actually carry a lot of the SD card with us and on the roads. It's a huge effort for my colleagues to be able to collect the data. The purpose is to try to understand what is the US road conditions, the driving scenario typically look like. So it's providing the basic input for us to develop the driving functions. So these are actually the coverage that we did. Some of the roads it's still under testing. We are still working on that, but we have tried to really cover a majority of the US cities and areas and regions. You can see on the West Coast and the East Coast, we spend a lot of effort in doing the data because that's actually the density of the population. So overall, we created like 50,000 miles. So far, that number is still growing. So this picture shows you the current programs that we're working on. It's Vietnamese electric vehicle from VinFast. We are actually supplying them with the automated automated parking functions. So because this car is being sold in US, my job or my colleagues with me together is to help my colleagues in China to test the US conditions, because the core development is done in China, but we need to test and validate if the function is working properly here in the US. So we are driving the car in different scenarios in US, and we're specifically to find a special driving or parking lots which you don't really easy to see in China. Yeah, this is some global parking scenario data we collected across the whole world, including also the Europe and covering the UK and also Germany, Spain, and Italy. These are a lot of effort that we have to go to go through in order to cover the global scenario for parking functions. So we're also involved in some of the ADAS robustness testing. So this is the testing we do for a third party who developing the ADAS functions like AEB, autonomous adaptive cruise control. We're driving a car in US roads and we're doing the different type of testing and trying to see how robust these functions. Here's just some of the coverage of the North America region. The data we are using is, my colleagues has made this slide. It's actually give you some sense about what is the possibility to share the data back to our engineering office. We can use a very expensive options like use the Amazon, Microsoft Seagate cloud, and they're providing a good service for transferring the data in a very fast speed, but it's very costly. We try to use a more economic way to do the data trend workstation in our own office and upload to the Ali cloud, so my colleagues in China can calculate that. This is actually the broad choose data workflow. As I mentioned, the broad choose is used as a reference system. So you develop a sensor. The sensor is sensing the objects on the road, but how do I know whether they are sensing the objects in the very accurate way? So you need to have a reference system to compare against. So the LiDAR, because it can deliver high accurate velocity and distance estimation, we typically use the LiDAR data as our reference after proper calibration, together with also some high accuracy RTK and positional data. So we are doing a data collection, and also use the offline post-processing method to do comparison. Finally, we want to generate the KPI report for different sensors in terms of their performance. So this is a short video that maybe I can play this video? Yeah, this is actually the video of a broad choose system. Yeah, this is actually from RoboSense. They made this video to show basically how a broad choose LiDAR-based broad choose system is working. As you can see here is a let's get it started. Okay. Yeah, basically you can see that this fine point is being processed to display the lane detection, the moving objects. It's I don't know why it's the quality is degraded, but basically it shows the moving targets like the bounding 3D bounding box, and it's synchronized with the raw view data. Maybe can you maybe just pick the full screen mode? Yeah, I think it's a resolution issue. Yeah, just play like that. Yeah, it's much better. Yeah. Probably just because the screen is too big. Yeah, it's maybe better. So basically, you can see there's 6 cameras capturing the actual real-world scenario, and the LiDAR is sensing all the objects and elements on the road, and it understands all the distance, velocity, lateral direction, longitude direction. So our sensor data will be used to compare against those structures to understand the thing. Yeah, please go to the next slide. I think it's for autonomous driving or ADAS function development. The simulation is a very important method, and we, like others, we are very much rely on the simulation tools to generate virtual world data, so we can create more corner cases that you probably cannot easily encounter in the real world. It provides more opportunity for you to challenge your system in the early stage, especially if you don't have access to the hardware. Of course, the real world data, the road testing is not being replaced. It's just a great method to do development in the early phase to identify some major issues that where you want to improve. The next. And maybe the last video I want to share with you is about CalmCar itself. So this is actually the video we just, my colleagues at the Shanghai Auto Show, they just made yesterday. I asked them to share with me, I can share with you, you can see what's going on directly in the Shanghai Auto Show. They published this video directly at our booth, CalmCar booth at the Shanghai Auto Show right now. Basically, it shows the work we have done in the camera-based perceptions and the different connection, environmental conditions. These are the automated parking functions in different scenarios. This is under the shopping mall. So basically, there's different applications in China. I would say this is a very interesting topic in China because the new electric vehicles, it's getting very smart now, and especially the end users who are using the car, they expected the car to be intelligent. So they wanted to have this parking function to be part of that. It's not the case so far in the US. It's especially, I think, we don't typically have a lot of issue with the parking space. That's why I think it's the demand for those auto driving functions are a little bit different. This is just to show you when the drivers can call the car, leaving its own designated spot and moving by itself to the drivers, and letting the driver to step into and drive away. So it's called summer mode, right? And this is the car is searching the parking spot by itself. This is actually a Zhou Automotive. I'm not sure if you heard about it. This is a Zhou Nezha. It's a Nezha. Yeah, Nezha is the brand of that vehicle. We are the supplier to this particular vehicle for the automated parking function and the 360 visualization. So this is actually Mercedes-Benz in Beijing. They actually asked us to provide also a parking functions for their test vehicles. Some of the work we've done on the highway as well, we do the similar work in the US. This is actually the driver monitoring, the last page is driver monitoring system, like the previous speaker talking about how you can identify the driver is drunk or he's too tired, he's closing eyes using cell phone. This can be identified by the cameras and providing warning, and of course the decision is to be made by the driver side. Okay, that's all for my presentation. Thank you very much for listening.
Thank you, everybody. Question? This topic and my topic is so related, so I need to ask a question. So, for the camera or LiDAR, right, the lens get blurred, especially recently during the snow season, is given. what do? You have some cleaning device or you automatically cleaning rather than somebody?
Well, there's a very classic question to the camera guy like me. So it's first of all, there's a requirement for the camera usage. You need to detect a misalignment. Like the camera needs to be mounted in the proper way, right? It's getting fixed, it doesn't shift its position. But along with the usage of the car, you have a bumping. Sometimes the mounting position of the camera can be a little bit shifted. So that's actually causing the need for recalibration, right? I think Wanda is the top expert in this domain. So it's the misalignment detection is done more or less automatically because we have constant access to the view of the camera. So that's number one. When the system detects the camera is shifted from its original mounting position, it provides the alarm of alert to the driver. You need to probably go to the dealer, or if there's a smart enough, it can do the auto calibration for you. The second question is to directly to your point is the blockage of dirt that is actually covering the view of the camera. And you also get a detection from the system. You're going to be alerted that you need to do some actions about that because you don't expect to put a wiper automatically clean it, or you can spray some liquid on that. This is not typically what people expect to do. I think it's we see a lot of RFQ from our OEMs asking for automatic detection mechanism to get the driver alerted, because that's the driver's responsibility to get rid of that and bring the system to the normal functional condition.
One more question.
Thank you so much for the good overview. You have a lot of sensors there, camera, LiDAR, radar, right? And each one have its own strength and weakness. So I wonder, when you do the sensor fusion for different road conditions or different weather, do you try to give different priorities to the data of different sensors? For example, during the night.
Yes.
You use cameras, right? During snow, LiDAR is not good. So do you adjust that using sensor fusion?
Well, yes. The answer is yes. This is, I would say, this is a very comprehensive question, and also the answer needs to be also very comprehensive. And also, it's an engineering and a commercial question. So the sensor has a cost, right? And there's different sensors that have different costs and different features. LiDAR is more expensive, camera is getting cheaper, maybe ultrasonic sensor is the most the cheapest one. But each sensor has its own limitation, but it has its own usage or reason to use them. Like ultrasonic is perfect for collision avoidance for the near range. You don't need the LiDAR to do that. It's overkill, right? The LiDAR is good as long as your car can accept that price. So I would say, I think it's when we as a group of engineers come together to determine which sensor to be used. First, we need to know each individual strengths and weakness of each individual sensors. But we also need to know what is the boundary condition for me to use in terms of the cost, in terms of the reliability of the sensors, also the accessibility of those sensors. Sometimes you like to use one sensor, but it's not available to you. Or you don't know them enough, nobody else has been using them, getting worried. It's not a proof of concept, it's really some product you want to deliver to the market so people can use. Because the previous pages mentioned the vehicle report is everybody trying to avoid. So we want to use something very reliable, delivering a robust and acceptable. I wouldn't say currently there's no ADAS system is delivering a perfect performance. There's nothing like that. But within a certain boundary conditions, with understanding as an engineer, understanding the strengths or the weakness of each individual sensors, you're going to make an optimized decision to select a group of a suite of sensors that can achieve your engineering goal within your commercial boundary. So that's actually the way how we see this. But in go to a purely technical question, we don't act like a Waymo or cruise automation. They don't really care about cost, but we are really focusing on delivering a production level products. So we really care about the cost and really care about the life cycle of the products. That's why it's a very comprehensive question that's not only the supplier like us to answer, it's a hard question to be answered by OEM, Tier 1, and the people like us, we are Tier 2 supplier. Thank you.
Thank you, Dr. Wang. Present your plaque by the CEA. That's our tradition. Thank you, Dr. Wang. I would like to have you here on the next arrival.
It's a yellow ticket. It's 777039.
Oh, okay, I got the ball.
The biggest one.
The biggest one, listen carefully.
And the other line.
777011. 011.
It's a yellow ticket, 777011. Going once, going twice? Okay. Again.
891-8978. The last 3 digits, 978. It's a red ticket.
The red ticket, 978.
Okay.
Again, going once.
One more time. Back to yellow. 777017. 017. We have 017. Right here.
Congratulations.
Closing remarks.
So it's time to say goodbye. I'm glad to see you all here. It's a good time to get together. Thank you for being with us, and I really appreciate for your time and participation. And let's make this happen more often, and let's see each other next time. Thank you, and safe flight. Goodbye.